Continuing electronics course, speaking about BJT, which is bipolar junction transistor. And here are different types of BJT with different models. What is bipolar junction transistor BJT? It's a semiconductor device constructed with three dipole semiconductor regions. We have base, collector, and the emitter, separated by two p-n junctions. So the p-n junction between the base and the emitter has a barrier voltage V0 of about 0.6 voltage, which is an important parameter of a BJT. So the BJT is like connecting two diodes together. Not exactly, but because if connected two diodes, we have four regions, but here we have three regions. So in BJT, current is produced by both types of charge carriers. So if it is electrons or holes, hence the name bipolar. Bipolar coming from this. It's the current produced because of the both electrons and the holes, positive and negative charges. Okay, and here connection, electric connection showing how NPN junction or transistor is showing BJT, and real how it's constructed. And we have E, B, C, E for emitter, B for base, and C for collector, as we said before. And this is more detailed. Here we have the base connected to the voltage and the collector and the E points. Okay. Types of BJT. There are two types of BJT: NBN and BNB. ماشي. Okay. N for A negative, positive, negative. BNB positive, negative, positive. The NBN type consists of two N regions separated by B region, and so on with the NBN, the BNB. So the diagrams below showing how NBN connected N region, B region, N region. We connect a B region by base connector, and N, the first N with C collector, and the second N with E connector. So and this NBN, the currents are appears here. So in NBN we have outcome current from E, so the arrow is outputting. And here are the voltage across the NBN. So we have VE, which is the voltage between the base and the emitter, and VC, which is the voltage between the collector and the emitter. Okay, and there is also another voltage, which is the BC voltage, or the base to collector voltage. Okay, we reverse the things with BNB. Okay, and the diagram showing that. So the IC-VCE characteristics curves of an NBN is illustrated in this Cartesian diagram in the first quarter. And we have here in the horizontal VCE voltage, and in the vertical IC بالمليامبير اللي هو I collector, and we have I base اللي هو base current for every point. Okay, or it's a diagram for calculating the table for I base for every corresponding VCE and I collector. Okay, saturation region, which is the last one. So I saturation is equals IC the maximum when VCE is equal to 0. Okay. Regions of operation. The modes of operation can be described in terms of the applied voltage. The prescription applies to NPN transistor. Polarities are reversed for BNB transistor, as we said before. Forward active. So forward active, we are here in speaking in NPN. Forward active, base higher than emitter, collector higher than base. يكون البيز higher than emitter وكمان الكوليكتور higher than البيز، يبقى ده forward ايه؟ forward active. In this mode the collector current is proportional to the base current. الكوليكتور proportional to the base. وانا عندي هنا في حاجه اسمها بيتا اف، وهنشوف البيتا اف هتكون كام في حاله الفورورد. في saturation mode البيز higher than emitter but collector is not higher than base. يبقى هنا البيز higher than emitter but collector is not higher than base. الكات اوف بيز lower than emitter. لما يكون البيز lower than emitter يبقى ده كات اوف. يبقى هنا لما يكون البيز lower than emitter في حالة ال NBN ده كات اوف مش هيطلع كارنت. البيز lower than الاميتر. اوكي يبقى كارنت ازاي يخش؟ هيطلع مفيش. يبقى ده كات اوف ريجن او كات اوف مود. بيز lower than emitter but collector is higher. وكان في نفس الوقت الايه collector is higher than base. It means that the transistor is not letting conventional current go through from collector to emitter. عشان كده الكوليكتور higher than base طبعا الكارنت هنا هيمشي من الايه؟ من الكوليكتور للبيز ومش هيروح للايه؟ للاميتر. فبالتالي هيكون ايه؟ هيكون ده اسمه كات اوف. الريفرس اكتف بقى لما يكون الريفرس اكتف بقى الكارنت هيمشي من الاميتر لمين؟ للبيز. ازاي بقى؟ لما يكون البيز البيز لور ذان الاميتر وكمان الكوليكتور لور ذان البيز. يبقى هنا البيز lower than الاميتر والكوليكتور lower than البيز. Reverse conventional current goes through transistor. In terms of junction biasing, reverse biased base collector junction means VBC equals 0 less than 0. VBC less than 0 for NBN opposite to BNB. And we here can calculate alpha F and beta F. And here showing diagrams and here showing connection, and I need this one, this good one. So when there is connection, when cut off, these circuits are not working. But in general احنا هنا نتكلم عن كله الحاجات دي هنا ايه؟ NBN because the arrow is outing from the emitter. So when no cut off, so the current is passing from the collector to the emitter. Okay, what is the forward active? في saturation base البيز higher than الemitter البيز but collector is not higher than base. ده saturation. البيز higher than emitter but collector is not higher than base. فهنا كده في saturation. في saturation. خلاص. الكات اوف لما يكون البيز lower than الاميتر but collector is higher than base. ده كات اوف. ماشي؟ طيب. هنا الكومن emitter is current again is represented by beta F or the parameter HFE. It's approximately the ratio. Please sound please. Please صوت الصوت يا جماعة. It's approximately the ratio of the DC collector current to the DC. الصوت يا شباب الصوت. The DC base current in forward active region. It is typically greater than 50 for a small signal transistor but can be smaller in transistor designed for high power applications. Another important parameter is the common base current gain, alpha F. The common base current gain is approximately the gain of current from emitter to collector in forward active region. This ratio usually has a value close to unity between 0.98 to 0.998. It's less than unity due to recombination of charge carriers as they cross the base region. And so we have alpha F equals IC divided by IE and beta F equals IC divided by IV. This is beta F and alpha F اللي هو DC gain. Okay. BJT as an amplifier. BJT class A signal amplifiers. In class A amplifiers, the transistor conducts for the full cycle of the input signal 360. Used in low power applications, the transistor is operated in the active region. In the active region, between saturation and cutoff. في الactive region اللي هو between saturation and active region. الactive region اللي هو between saturation and cutoff. ده اسمه الactive region. Okay. So the load line is drawn in on the collector curves between saturation and cutoff. Okay. And the diagram showing here. voltage amplifier circuit with a BJT transistor, and we have in this circuit the diagram, electronic diagram. We have here input voltage, then capacitor of 17 microfarad, and we have the combination of constructing resistor on this diagram and the BJT here. So this capacitor, another capacitor 10 microfarad voltage output. Electrolytic capacitor and battery of 1.5 voltage, and the connection in the body here. This is voltage amplifier circuit to amplify the input and get A out with high voltage. Okay. BJT emitter follower circuit. Its components and diagram as like here. It's the same like this one, but there is difference in the resistor connected to the collector of the NBN BJT. No resistor in the connected to the collector. Okay. And we have this. We see it before. Thanks for listening. I hope you to join our channel for knowing if any new videos or updating for the channel, and you can write your comment about this lecture or session. So if it's positive or negative, it will good feedback for us. Thanks for listening.